Hi guys, so this is Jeevan back on a new video in Grasshopper. So in this video we are going to do a stadium facade or the skeleton which I showed in the cover image obviously. So let's go into the video. So at start I'm going to start with the command rectangle. So in rectangle, I'm just giving a dimension of 200 and another value of 160. So I'm getting this number slider by double clicking on the canvas, so that when I double click on the canvas is nothing but the grid background. You just double click double mouse left button. I get confused with this. So you just double click your mouse left button so that on the canvas, so that you will get this, enter a search keyword. So just type the number, you get a number slider for 160, something like this. So you get a number slider. So you can see the names of the component and you can adjust this, like go into display. If you don't want full names, you just do this, like draw full name. You just alter it according to your comfort, and this is my comfort of work, so that you will understand where I'm connecting the circuit. So I prefer this one. So if you don't, you can change it according to your comfort. So by the way, I'm using bifocal. So bifocal is a component which gives a label for each component, so that which allows you to see the name of the component. For example, this is a rectangle, you see a label. So if I inactive, you won't see it. So when I'm teaching, or like when I'm doing a YouTube video, I always enable this component, so that if I didn't say the name specifically, or the name which I said, like you didn't get it due to my pronunciation or stuff, you can see in the screen clearly the name of the component. I prefer this one to be very useful. So let's connect 200 to x-axis, x-size, and 162 y-size. Wow, it's a little pretty big, you might think. Yeah, because we are going to design kind of a stadium, so it's something proportional to that. So I'll just hide this part. Now after hiding this component, I just hide this because like I'm going to use a curve vector, so which which reduces the confusion when you create a huge a diagram in Grasshopper, like huge flow chart. So you can see this curve as the rectangle value, but it doesn't show the plane and stuff, which I don't need. So I just kept the curve aside. So now I'm going to use explode command to explode the curve. So when it explodes, it gives typically the four line segment and the four vertices, that is the joining as a point. So I just need a segment, so I'm going to use curve again to avoid the confusion. So you can see it has four value inherited from one source. So I'm just hiding this. So I'm just I'm just clicking the preview of option, and if you don't know how to get this option, select this explode, then right click on the canvas, not on the component, then click preview off. So the green indication means that you selected that component. For example, I can select three components at the same time, right click, and you can do the preview off simultaneously for three components also. So now you can see four rectangles, four lines there. I just want the line to be scaled little inward, so that I want to make the line shorten in all the four directions. So one way is like you can do like a scale option, but another way which I prefer is extend curve. So you might ask, bro, you are going to shorten the curve, but you're going to use extend. So extend, if like if you're using extend in a negative way, then it's shortening. So maybe I'll show you. You'll get to know when I'm doing. So I just connected the curve. Now it asks for start and end. Maybe for example, I'll show some value in positive so that start and you can see the end value is being extended. Maybe I can wait. So you can see the end and the start is being extended by a value of 10. You can see the line is being extended. So what I'm going to do is I'm going to use negative, and now I'm going to use 10. So you don't see any difference because there's already a curve which has been overlapping. So you can see the curve has been extended inward, which is like kind of shortening. So the negative value makes it the reverse of what it means. So instead of giving a value with 10, I just make a proportional towards the number so that I don't want to create a lot of number slider. So if I edit this number slider, all the numbers which is proportional to this number slider should be edited. So I always try to make in that way. So I'll just create a multiplication. So I'll just give the connection 160. Now I want this value to be shortened. Like I don't want 160. You might think multiplication increases value. No, I'm going to give 0.20, which is typically kind of a division value. Like now it reduced as I given 2 points with a point of 20. It's kind of 32. It's kind of reminder division. When you multiply the whole number like a decimal number, it's typically a kind of division. So now you got the four lines. Now you may wonder, why did you first create a rectangle and why did you shorten it? See, I'll just show you. I'm just going to do divide curve. I just want a elliptical kind of a rectangular in a way of elliptical way. I can extract from through this process. So I'm just going to give a divide curve. Now I'm going to give a curve. I don't need these many points. Maybe I'll just go with one that is start and end. So now I'm going to turn off everything. I just want to see only the points. Now I'm going to give nerve curve. So you can see the curve is not been connected. Maybe just see, you can see the point like this is the first line point, this is the second line point, but I want a sequence of point. I don't want this break. So I don't want this list. I want 8 points which creates an so I just want 8 points. So when I do the flatten, you can see the list consists of 8 points. You might see the 7 because it takes 0 as an entity. I just close this so you can see this, but I want this to be closed. So go into periodic, go into invert. So I just want something like this. So I just turn off the other elements which I created before, and now I want a point like here and here. So what can I do? Like I want a point from kind of a center one. Like As you see, it's like a, when I turn on this, you can see it is not connected. But I want to point in the exact center. What I can do is I can draw a line over here, and then the line which passes through this elliptical surface, you can take extract the points through that. So for that, what I can do is I need to take a component called curve line. So you can see the symbol. So the curve is there, the line. You can see points have been created where the curve and the line intersecting. So we got the curve, but we need to create the line. So let's connect the curve first. So I always go with SGL because SGL reduce the input values. So I'll go with the start. So I just want to be in the center perpendicular. So I'll go first. I need to find the center. So I'll go with the area. So connect it. So you get the area. So area becomes the start. And now I want the direction. I want it to be in the x-axis. So you can see a line has been created. I don't want this point to be visible, to be seen. So now if I connect this line, so it just project, it's kind of a projection option. So the line will be projected on the both sides and it will see where the line is intersected. Like when I click this, you can see 2 points have been created. So then this line is being projected towards the ellipse, and when it intersects, you get these 2 points. This is what I was looking for. But I just turn off the preview, and now uh, you might be thinking like, why do we need this point? So this point is going to be the reference point for the next ellipse which we are going to create. So now I'm going to create. I want to select the items like list item. So because there's 2 points, but I only want this point to be selected for right now. So I'll just preview off and I click this. So this is a list item component enables you to select a particular item from the list. In this list, it has only two values. One is 0 and another is 1. These are the index number. So you can see by default the index number is 0. The index number 0 is like 191. For example, if I change it to 1, you can see this point has been selected. So the component allows you to pick any item from the list. So for now I just need this point. So now I'm going to adjust the seam, by the way. Like for example, if I use divide curve like this, sorry. So if I divide the curve, you can see the curves are being divided. You can see the point starts from here. But when I use this point and I use this curve, you don't see any difference. But this, so when I click the divide curve, you can see the point, the dividing point is starting after the point. You can see, so this is the seam. That's like seam. You can see it moves the point with the reference of the point which is already there. So you can change the vector seam, like it is not kind of rotating, you might say. It's like you're just changing the attribute of the curve. So here the position is not changed because in a circle you can just but in this point if you can't rotate it like as it is. Okay, I just want to know the seam, the direction of the seam, so that the model when I do, you can see in the cover that the facade is being angular more, it doesn't be in the angular moment. So for the seam is the major entity. So now I'm going to divide the surface. So I'll divide the curve So I just do at 20. Let's preview of everything. No, I just want the curve. So now I'm going to move it. So now you will get an idea of what I'm trying to do. You see an zigzag pattern in the image on the top of the stadium. So I'm going to create that with move. So now I want this point to be moved in a way. So now I want this point to be moved in a zigzag pattern in a way that when I connect the nerve curve, it creates that pattern. So I'm going to use a basic mathematic equation over here. So I'll just show you. So the curve should be moved in unit set, just now I'm going to create the mathematics like the expression. So this is the expression editor. So let's make it to be x. Let's make it to be r. So first I'm going to do cos x into r wait a sec. Cos this is a bracket with x and into r. So the error is like unknown variable encountered as well. Like okay, so the variable like I've given x. So what you can do is edit the name to x. Now it says function cos can only be calculated with numerical parameters. So I need to connect some value for x which enables the value. So what I can do is for now I can give a value of 1, maybe the numerical value. Now it shows a syntax error, unknown variable encountered r. So what it's saying is like we don't have any value, we just have variable y. So what you're going to do is change it to r. So right value of the operator is null. So it says like the r value is empty. Maybe I can give a value of 10. So this is how you just work on the syntax, like sorry, expression. So you just need to check the error, like what error it shows. Cos x into r. So this is the major combination which I'm going to work. So now I'm just going to add this in unit text. You can see there's not a much big difference because I just want to work on x because I want like different values because you see there is around 20 points and the expression provides me only 1 point. So for providing multiple values I just use range or series. So I need 20 values because I divided 20 points, so obviously it's 20. Sorry, the step should be in 20. And you can see when I click the mouse, you can see 21 locally defined values. So range provides you one extra value. So go into expression, type x minus 1. So if the value is 21, it reduces to 20. You can see 20 locally very different. And like, let's make the domain to be pi. I'll just take a panel, pi to 5 pi 5 into pi. I hope this works. Yeah. So you can check the value. So you can see it's been like pi into pi to 5 pi. So let's see the value. So you can see. Wait, I'll just connect it to nerve curve to get a clear understanding. To close the nerve curve, what I said to do, I go to periodic, turn inward. So I just turn off the preview, and now you can see 5 to 5 pi. It's kind of the basic mathematics, like pi is like 3.14. So it allows you to create a pi to pi or pi to 1. So it's a basic mathematical constant value which you use into multiple terms. So this is like fine, but let's play with the expression. I'll just put plus another r, like no syntax error detected in the expression. So plus r means, like, for example, cos x is like cos for cos 1, maybe, for example, plus, sorry, into 10, that is r. So this one gives you a value, some kind of value, but you could see the values going beneath the curve. So I just put a plus r, that is plus another 10. So by this way it increases the value, increases the height, because all the value which we are giving, it's going to be in units that direction. So it's all the way, it will be in vertical value, but the value should be in different ways. So the cos x into r creates you the pattern. So the plus, like, it is a basic rule of board mass, like for example, board mass. So board mass is bracket of division, multiplication, addition, subtraction. So first it sort out the bracket, then it goes with the multiplication, that is cos into r. So cos into r is a expression which creates the pattern, whereas plus r is like it goes after the multiplication, that is gives the value to the height. If you want, you can add another value. So in this case also it's the same. So it adds, so at the end of the day, at the end of the equation, it has sum up with the value 30. So the value is the 30 is, for example, z is 30. So the value of 30 has been added to every point. So the every point is being lifted up with the z value. So this pattern is being created by cos x into r, and the addition gives a value, it's a constant value, like it's a constant value given to all the points. Okay, so So what I'm going to do is I'm going to create a bracket. So you can see no syntax error is being found, plus maybe Z. You can create your own expression. There is no problem in that. So I'm going, when you zoom in, you can see a plus. I'm going to change it to Z, maybe 30. So this is how the concept works. So it goes like so. So this point is like when I increase the number of points, the value you can see that the curve is been altered in a way with the dividing point. I want it to be in 20. Let's zoom in. Yeah. Ah. Okay. So we got the curve. So now what I'm going to do is I want a sequence, not a sequence. I want another curve in between these two curves with proportion to this shape. So what I'm going to use is twin curves. So you can see in the image, so it creates a curve with reference with the two other curves. So the first curve is a scene curve and it is the second curve. Now the factor, I just give the factor with the help of range component. So you can see it creates a number of curves because by default the step is defined as 10 locally, but I just give it as 2. So you might think 2 means by range. When you're using a range component, it means like it has plus 1. So it's 3 value. So we got this 3 outer shape. So now what I need is like the curve should be closed. I want the 3 curves to be scaled in. I want the 3 curves should be scaled inward, like inside, so that it gives an opening for the stadium. So what I'm going to do is I'm going to divide the curve. So twin curves, so I'm going to divide it maybe with a proportion of 20. So that is great. And now I'm going to do a scale. So you could see the scale factor has been created here, but I just want the scale to be in the center. You can do like the same one. You can get area um, in the curves, and then go the area. So you can take the curve, then find the area or something. Or else, what I used to do is I go with average. So the input values, like I input the point, it gives an arithmetic mean. So which is just center, which provides the center. So I will just give a center. And now you could see like I have like a lot of curves inside. So I'll just keep the panel to check what is the problem. There's only 3 points, then why do we have this many curves? And you can see these numbers. Always when you check this number 1, 2, 3, 4, it's kind of generation, so it's kind of 4 generation. So when I'll check with twin curves, it's like 3. What I'll do is like I'll just, and you can see in this list there's nothing a break. So a list consists of 3 values, but in this a list consists of 3 sublists. So this is one list, this is one list, this is one list. I don't want this, so let's flatten it. So I want something like this. So now it matches up. So let's see. Yeah, this is what I was looking for. So now the scale factor is done. So if you want, you can just rebuild your curve for more values. And now I'm just going, I'm going to loft. Before lofting, let's rebuild the curve. Rebuild the curve for like 20. Now let's loft the curve. You can see the scale. So actually I don't want this. So I don't want any of this curve. So what I want is I just want this 3 curve which is being scaled in the center. I just want the factor to be different factors. That is, for example, I'll just go merge. Now I want 3 factors. The first curve should have a scale factor of 1. And the second one should have a scale factor of 1.0. The third one may be 0.93. Just a random value. And let's give it. So you can see the scale factor so it's simple. What I'm doing is it has 3 input values, so I'm giving 3 scale factors so it matches up with the list. So if you want, you can alter each one value. So this is my way of working. So the scale factor has been altered. Now I'm going to use loft. If you want, you can rebuild the curve to get a smoother one finish. So you can see the surface which we are trying to get has been created. So if you remember this, it's replicate another famous architecture structure shape. So right now this is done. So now I just want to create the pattern which I created before. What I'm going to do is I'm going to do a divide domain square. So you can see the icon. Most of the time Grasshopper explains what the component will do through the icon, and if you don't understand the input value, click just give help, so it allows you to know what kind of input value you need to be given. So I'm giving one. This one is 50. Now I'm going to use ISO trim. So this is going to trim. So this is going to trim based on the divide domain. So you can see it's being trimmed. So I just want 50 or some random numbers. I just hide this. So it's been trimmed. So each element, each segment, we are going to replicate with the design. For now, I'm not going to do that design in Grasshopper because you can replicate whatever element you want. So I'm going to show that and do that in Rhino. So maybe like I just create a rectangle, then I created line. Now I'm going to use 3-point arc. Now I'm going to delete this line which I don't need. So now I'm going to draw a perpendicular line, vertical line. Now I'm going to use the same 3-point curve. Sorry. Now I'm going to draw a line over here. So sweep 2. It creates a surface. Now I'm going to use mirror. I'm going to use join. So this is just an replication. Not this big extrusion. I'm using gumball to give it a thickness. I'm going to delete the surface which I created beneath. Now I'm going to connect this, use pooling union to merge. Now I'm going to use merge or planar surface. So for now this is done. So let's do grip. Let's take grip. Now I'm going to select one grip. Now I'm going to initialize data so that the data is automatically initialized with the grasshopper so that I can delete this which I don't need. So this has been initialized. So I just want this pattern to be repeated in all the linear element. So I'm going to use surface morph. Surface morph. So I'm going to give the geometry. Next, bounding box. So bounding box will create a reference bounding box. So now I'm going to give it as a reference. So the surface is obvious this. Now the domain is like 1 because like I'll just say why we are going to give this u1 v domain as 1. Let's be the w domain as 2. You can see nothing changed. It's because like the surface should be reparameterized because we gave the domain as 1. Because of that that's why we gave the domain as 1. We know that we are going to do the reparameterization. Let's turn it off so you can see the element which I am trying to do. So in this way you can create your own element and try with this surface and share some creative result which you are trying to me so that I can see some innovations through your ideas. Okay, thank you, have a nice day, see you on the next video, bye bye.